How do you know if your software is ready to release? People have tried all sorts of things to try and answer that question. Is it ready? In continuous delivery, we're trying to achieve a more repeatable, reliable outcome. So how do you shift from manual testing or flaky, fragile, functional tests to executable specifications? Hi, I'm Dave Farley of Continuous Delivery. Welcome to the Continuous Delivery channel. Please hit subscribe, and that way we can keep you informed of future episodes, and hit like or dislike whichever you think is appropriate. In this episode, we're going to explore what it takes to create executable specifications rather than functional tests, and explore the ideas of why that matters. We're going to describe 6 properties of acceptance testing. Why do we need executable specifications? How do we create those executable specifications? And I'm going to give you my top tip for how to integrate all of this together and drive the development process. This episode is based on a module in my acceptance testing training course. If you're interested in that or any other training courses, there's a link below that will give you more information. Acceptance testing is described in the Continuous Delivery book. There's a chapter dedicated to the topic. I think one way of thinking about that is that it's really about all of the user-centered testing, not evaluating from a technical point of view, but from a user's perspective. You can think of everything post the commit stage in the deployment pipeline as a form of acceptance testing, I suppose. But the piece that I'm really focused on and interested in is this, the acceptance testing stage, which is really driving that user-focused evaluation of our software. There's a nice model. This is based on Brian Marrick's testing quadrant with a little bit of revision, in which he describes the different styles of testing. We're looking at business-facing versus tech-facing, and testing that supports programming versus critiquing production evaluations. And we divide that then up into functional testing and acceptance testing, unit testing and integration or component testing, exploratory and usability testing, performance, security, non-functional requirements, and so on. The top left quadrant is really what we're talking about today. We're talking about functional testing and acceptance testing, and that's what we're looking at. So this is business facing, and it's supporting the programming, the development of our systems. So what is an acceptance test? Here are my 6 properties. First, we're going to assert that the code does what the users want the code to do. We're going to focus on trying to achieve a behavioral specification that captures the intent of the user. We want an automated definition of done. If we can take this specification and use it to drive our development process, it gives us a great way of understanding when we're finished. It keeps us focused on the work that we're doing. If you can imagine creating one of these specifications before we begin development, and then working using TDD underneath until that specification is fulfilled, that's a great way of driving development. An acceptance test also asserts that the code works in a production-like test environment. That means it gives us an opportunity to test the deployment and the configuration of the system, as well as the normal behavioral qualities of the system. The other important attribute of an acceptance test is that it gives us timely feedback. We want to find out just in time that our change is no good, rather than just too late. And finally, we want our tests always to be repeatable and reliable. We want our tests to fail if there's a problem. We want them to use them as a tool. A failing test is more important than a passing test, because that's the point at which we're getting the strongest signal back from our system, at the point at which the test fails. So those are my 6 properties of acceptance tests. If you've got any others that you think are valuable, please put them in the comments below. We'd love to hear them. One of the common ideas that is confusing to people is the difference or distinction between behaviour-driven development and acceptance testing. And I think that these are two facets of similar things. There's a bunch of terminology in this space. For the purposes of this video, I think that we can treat all of these terms: acceptance testing, acceptance test-driven development, behaviour-driven development, and specification by example, and executable specifications as synonyms. They're all kind of one thing that we're trying to describe. We're trying to capture from a user's perspective the intent of the system. In terms of the differences, they're kind of subtle. BDD, I think, is broader in some senses, as you may see from this video. If you follow this link, my thoughts on BDD are that it's more broadly applicable to automated testing as a whole, allowing us to drive these specifications at all levels of granularity into our code. But let's start thinking about what a good acceptance test is. An acceptance test is an executable specification for the behaviour of the system. I often use this diagram to represent the idea of continuous delivery, this diagram of multiple feedback loops. And the feedback loop that we're focused on here is this one. We're trying to get this slightly higher level evaluation rather than just the technical evaluation of TDD. We're getting a higher level evaluation from the perspective of a user of what the system does. So why do we need these executable specifications? The problem is that there's often a disconnect between what users want of a system and what the software actually delivers. And that's often down to a break in communications on the route to the development of the software. It's difficult to be able to identify a user need, and then it's difficult to design a solution that fits that user need. All too often, we make the mistake of bundling those two ideas, those two difficult problems together, and creating an unsolvable problem. So if we tease those things apart, if we focus separately on what the user wants of the system, and then think separately on how we will achieve that, that gives us more opportunities. So we're trying to avoid solving both of these difficult problems at the same time. For most organizations, when they're trying to answer the question, is it releasable, they turn to functional testing, manual acceptance testing. It's kind of a default assumption that only human beings can say, yes, it's good enough to go into production. The trouble with that, it's not a repeatable and reliable process. It's slow, it's inefficient, it's expensive. Many organizations, in order to try and improve the repeatability, will start to script those interactions. So you'll get manual testing driven by scripts, at which point you think, what's the person really doing, playing the role of just a robot in this process? This approach is slow, low quality, expensive, unreliable, error prone, and results in hard to understand test scripts. The next step is often to move on to automate those tests, to automate those scripts. And you tend to end up with something that looks a little bit like this. This is a very simplistic step through the process of evaluating a system. There's a problem though. This kind of automated functional test often breaks as soon as the system under test changes. These tests are slow to develop, low quality, expensive, unreliable, error prone, and fragile. So how should we think about building executable specifications to get around these problems? The problem here is one of coupling. The tests are coupled to the system under test. If we want the freedom to be able to develop and evolve the design and implementation of our system, we need to break that coupling, reduce that coupling between the tests and the system. What we would really like is that we'd like to be able to create a test script and for it to be sufficiently loosely coupled that the system under test can change freely without requiring us to change the test script. What we need to do to achieve that is we must very, very clearly separate out what the system does from how it does it. And the scripts that we write should say nothing at all about how the system achieves its ends. The solution is to come up with a language in which we can express those what scenarios. And what we'd really like is kind of a shared language for expressing a user's need. It turns out we've nearly always got that language. It's the language of the problem domain. So, some tips for how to start getting this language of the problem domain appropriately decoupled from the system under test. First, always capture any requirement from the perspective of an external user of the system. At this level of testing, that's pretty much essential. Next, avoid any reference at all on how the system works. My advice is to always imagine being able to take the test that you are writing and apply that to a completely brand new version of the system. Imagine throwing away the system that you have, changing the user interface, rewriting it in a different technology. Could this test still make sense? It should. It should be able to achieve that if you've got this separation right. Focus on what the user wants of the system. That's the key goal in expressing these things. And link these executable specifications that you create to user stories. Tie them together using that language of the problem domain. That also helps to keep these things clean of dependency on how the system works. A useful technique for this is to make the team's definition of done a minimum of one acceptance test for every acceptance criteria associated with every story. This starts to join together your development process. It starts to make it a more coherent whole. Imagine the least technical person that you know who understands the problem domain reading the tests that you are creating. They should be able to understand what the ideas that you are expressing. That's the level of abstraction. I used to joke, imagine trying to show this test case to your non-technical grandparent, and would they be able to understand the ideas that you are expressing? It should say nothing about the technology or how the system works. Avoid technical stories at all costs. Always try and dig in and find out what the fundamental need is. Technical stories are nearly always a cheat. If there's no real reason to be making this technical change, then why are you doing it? There should be some value, some impact that you are seeking. Try and capture that in these specifications. Make each requirement, each story, each specification as small as possible. We'd like them to be focused on a small unit of behaviour. I'm going to have more to say on ways in which to organise user stories in the future on that topic, but think about how you can decompose these requirements into small steps that are visible to an external user of the system. That too is an effective way of driving good practice in your development approach. In his fantastic, influential book, Eric Evans, when he wrote Domain-Driven Design, introduced the idea of ubiquitous language. Ubiquitous means everywhere. It means it's spread everywhere. And in this context, that's what we're talking about. What we're trying to achieve in order to establish a ubiquitous language for our problem is when we talk about the system, whether it's in the context of the analysis of the system before we start thinking about breaking it into requirements, the requirements themselves, the ways in which we're going to test it, and in the design of the system itself, the language that we use should be the language of the problem domain. We should work to try and establish a consistent grammar that's always correct, that when we say an idea, and we should be picking one another up if we misuse terms and try and be careful about the words that we choose to describe ideas. This is the idea of ubiquitous language, and it's a fundamental core of this kind of thinking. It gives us the opportunity, if we establish this ubiquitous language, to link together the work of the broader organisation, the businesses in which we operate, the requirements process, the testing process, the design process. All of it is joined together through this ubiquitous language. It allows us to express ideas and communicate between different parts of the organisation, and it makes us build better software. If we are organising our thinking around the model of the problem domain that is expressed by the ubiquitous language, a change in the business is less likely to surprise us and invalidate our assumptions, the assumptions that are built into our software. So that last is my top tip. Establish and use a ubiquitous language. Use the creation of executable specifications to capture that language before you start writing the code to fulfill those specifications in the ubiquitous language, and use the development of those to drive out the ubiquitous language and refine and evolve the precision of the grammar in that language. So, in summary, establish the use of ubiquitous language. Use it ubiquitously. Separate what the system does from how it does it. Create specifications that talk only about what the system should do and say nothing at all about how the system works. Thank you very much for watching.